Hey guys, so here it's a video that will show you how to solve the equations I put for the distance and acceleration video. So I put two questions, two problems, and here I will give you the answers of each of them. So the first one. A car accelerates from 5 meters per second to 10 meters per second in 20 seconds. What distance did it do? So, first we're going to put, oh, sorry. I'm new to this. So, first we're going to put given variables. So, given. So, what do we know? We know the initial velocity, the final velocity, and the time. So, the initial velocity is 5 meters per second. The final velocity is 10 meters per second. And the time is 20 seconds. So, now we're going to put what do we want to know. So, we would like to know the distance. Okay, so there are two ways to do it. The first way is to use the graph and to solve for the area in the graph. So here we have our beautiful graph, and we're going to label the graph 2, 3, 4. So here's seconds and here's meters per second. 1, 2, 3, 4. Yeah, I can. So here we have 2, 4, 6, 8, and 10. And here we have 5, 10, 15, and 20. So let's say 5 is here. That's our 5. So we know it started from 5 meters per second, and the velocity went augmenting or getting bigger still until it reached 10 meters per second, and we know it did it on time of 20 meters per second. So here we have our final point, and so it started going, increases, and finally get it on the 20 meters per second. So we have our graph like this, and we want to know this plus this area. So the distance is equal to, what's this area? Initial velocity multiplied by the time. Initial velocity multiplied by time plus this area, that's a half. Remember the formula for the triangle, it's a half multiplied by its base multiplied by its height. So a half of the height, that it's the same thing. So the height is the final velocity minus initial velocity. So we just have like this little line here. So plus a half of the final velocity minus initial velocity, and this multiplied by the time. So the distance is equal to initial velocity, so 5 multiplied by the time, the brackets are multiplied by the time, plus a half of final velocity minus initial velocity, and that is multiplied by the time. So the distance is equal to 100 plus a half of multiplied by 5 multiplied by 20, sorry. So we have the distance is equal to 100 plus a half of 100. So do you know what's a half of 100? So here equal to 100 plus 50, 150 here, meters. So here we have the answer is 150 meters. Great. Now uh, let's get a new one. Yeah, new one. Now we're going to do it the other way. That's with the formulas. So you can either calculate first the acceleration and then put it on the formula d is equal to initial velocity multiplied by the time plus a half of 80 squared, or put in the formula distance is equal to final velocity multiplied by the time minus a half of 80 squared. So for this purposes we're going to do with initial velocity because it's simpler, or no, let's do it with final velocity. So first we're going to calculate the acceleration. So the acceleration is equal to the final velocity minus initial velocity over the time. This is equal to 10 minus 5 over 20. That's equal to 5 over 20. That's equal to 0.25. Now we're going to do it with the formula v is equal to the initial velocity. Initial velocity multiplied by time plus a half of a t squared. So for that numbers 80 squared. So that's equal to initial velocity 5 multiplied by the time 20 plus a half multiplied by the acceleration. So the acceleration will be 0.5, and this is multiplied to the time squared, 20 squared. So that's equal to 5 times 20, 100, plus we're doing this first, or you can just use your calculator to do it, and you will see that this is 50. All of this, that's 50, and that's of course equal to 150 meters. So we got the same answer. Okay, now so